Welcome again to today's maths lesson. We are continuing with our topic on the length, area, surface area, and volume. In our past lesson, we were able to look at the length and perimeter, where we said that given 2 points on a plane surface, let's say point A and point B, when joined with a straight line, the measurement of the distance between these two particular points will give you the length of point A and B. We also said that the perimeter is the distance all around a closed figure or a closed point. So in this case, we said that a perimeter is normally given by total distance round a closed figure. In those particular closed figures that we considered, we never considered a circle, and that is what we want to begin looking at it right now. So if the figure in question is a circle, then distance around that particular circle will not be referred to as perimeter, but will be referred to as circumference. And hence, circumference will be the distance around a circle. We also mentioned that if we have a closed circle like this one, then a section is chopped off with a particular angle being made, let's call it angle theta, then we shall have two sections of the circle. These two sections are the ones we refer to them as sectors. The big sector is normally referred to as the major sector, while the small sector is referred to as the minor sector. We are going to look at how we can be able to calculate now the perimeter of either the smaller sector or the minor sector, that is the distance from point A to point B via C. That will be the perimeter because it's not a complete circle. Also, after getting this distance from A to B via C, we can also be able to get the perimeter of the other sector, that is the major sector, from A to B via point D. So given that this is the angle theta, this can be 360, subtract the angle theta, given that the whole of these are angles at a point which normally add up to 360 degrees. Now, given a circle with center O and radius R, the diameter of this particular circle will be given by R plus R, which will be 2R. So in this case, we can be able to say that diameter is equivalent to 2R. And whenever you want to find the distance around this particular circle, we actually require to know the diameter or the measurement of the diameter of this particular circle. And therefore, circumference of a circle is normally given by the formula pi multiplied by the diameter d. But because already we know what the diameter is in terms of the radius, we have said that diameter is twice the radius, and therefore the formula can also be rewritten to accommodate the radius, to mean that circumference of a circle can be given as 2 multiplied by pi multiplied by r, which is the radius of that particular circle. Now, if we have a sector subtending an angle theta degrees at the center of the circle, we can also be able to find the perimeter from this particular point A to B, either via C or via point D. If I can be able to rewrite this equation and say that because I'm moving around at this particular circle, that this will be 360 degrees divided by 360 degrees, which represents angles at a point, multiplied by 2 pi r. Then if I'm going to subtend, or if I'm going to move for only a portion of that 360 degrees, then I can be able to find this particular distance from A to B via C whenever I have this angle subtended at the center of the circle. And therefore the perimeter of this particular sector shall be given by that angle which has been subtended at the center of the circle divided by the total angles at a point, which is 360 degrees, multiplied by 2 pi r, where r is given in that particular case, or theta all over 360 multiplied by pi d, where d is the diameter of that particular circle. We want to consider a number of examples on how we can be able to find the circumference of circles and also the perimeter of sectors. We note that the symbol pi, which is of that form, is normally a constant, which when written as a fraction is 22/7, or when written as a decimal is 3.142. So in case the question directs you to use 22/7, then we use it, and in case the question directs you to use it as a decimal, then you should be able to use it. Example 1. Find the circumference of the circle and sector below correct to 2 decimal places. Correct to 2 decimal places. But A, we are having a circle which we have been told has a radius of 3 centimeters. So given that this is a complete circle, we might want to, and we want to find the circumference, that is the distance around this particular circle. We have been given that the radius is 3. We're going to apply the formula used to finding this, the circumference of a circle, which is saying that C is given by 2 pi r, where r is the radius that have been given and pi is a constant. And in this case, we're going to use pi as 3.142. So in this case, we shall have 2 multiplied by 3.142 multiplied by the radius, which is 3. We are using pi as 3.142 because we have not been restricted. This will give us the circumference of this circle to be 18.852 centimeters. Still the units for circumference is the same as the units for the perimeter, which is the same as the units for the length. In this case, we are using it as centimeters. Part B, we have a sector of a circle which have been told subtend 100 degrees at the center of this particular circle. So in this case, for us to be able to find the perimeter or distance around this particular sector, we need first to know how we can be able to get the distance from this point to this point, that is the curved length. Then the two radiuses must also be included. In this case, the radius of this sector is 7 meters. Given that this is 7 meters, it also dictates that the other one will be 7 meters. Now we'd say that the perimeter of a sector of a circle will be given by theta all over 360 multiplied by 2 pi r. But in this case, because we are having these two other sides, then we must add twice the radius of that particular circle where the sector originated from. And this will give us P to be equal to theta. In this case, the subtended angle at the center is 100 degrees. So that will be 100 all over 360 multiplied by 2. Let us use 22 over 7 this time round, multiplied by the radius, which in this case is 7, plus 2 multiplied by the radius, which will be 2 multiplied by 7. Now 100 divided by 360 multiplied by 2 times 22 all over 7 multiplied by 7. These and these will cancel. 2 multiplied by 22 will be 44. Therefore, 44 multiplied by 100 is 4,400. When you divide that by 360, you'll get that P will be 12.222. 2 is recurring, plus 2 multiplied by 7 gives us 14. So when added to 12.22, we'll get that the perimeter will be 26.2222, and it's recurring. And in this case, this is meters. But the question requires us to write our answers correct to 2 decimal place. Therefore, when written correct to 2 decimal place, the answer for the perimeter in part B will be 26.22 meters. That means when you go from this particular point A to B to C, then back to A, you will have covered 26.22 meters. For part M, when rounded off, this will be 18.85 centimeters, which will now be the correct answers for both part A and part B. Example 2. We are told to give exact circumference or perimeter of these shapes. We have the first shape, which is a complete circle, and the diameter, which is the longest chord passing through the center of the circle, is 8 units. Then part B, we have we have a circle, but a quarter of it is chopped off. So that means we are left with the major sector, and this is 90 degrees. The radius of that sector is 2 units. Now we are supposed to find the perimeter around this particular shape and the circumference of this particular circle, but the point here is the exact. We all know that whenever you express pi as a decimal, you can never manage. That's why pi is one of the numbers that we refer to them as being irrational, since when divided, or when you take 22 divided by 7, you will find a decimal that is neither recurring nor terminating. And these are some of the numbers which the Pythagoras referred to them as unthinkable, or numbers which were not supposed to be mentioned anywhere. And that means that instead of us using an expression for pi as either 22/7 or as a decimal, then we avoid that and we use pi the way it is in our expression. That means we express the circumference of the circumference or the perimeter of our shapes using pi. So we had said that when given the diameter, circumference of a circle is given by pi multiplied by d, where d is the diameter. We have been told that the diameter of this particular figure is 8 units, and therefore the circumference shall be 8 multiplied by pi units. So for the purpose of being exact, we leave our answer consisting or with the expression of pi the way it is. For part B, we have part of this particular circle chopped off, and they have chopped off a quarter of our circle. That means whatever we are remaining with from here up to here around this is a half, no, is 3/4 of the whole circle. And therefore, for you to be able to get the perimeter around this particular shape, then you take 3/4 multiplied by pi d, then you add the distance or the two radiuses, that is 2 plus 2. Now this will give us 3/4 multiplied by pi. The diameter, because the radius is 2, will be 4 plus, this will be 2 plus 2 will give us a total of 4 units. So when you take 3/4 pi multiplied by 4, 4 and 4 will cancel, leaving us with 3 pi plus 4 units. And this will remain to be the perimeter of our given shape. Example 3, we are told to determine the circumference or perimeters of the given shapes. We want to consider where we are now going to use the angles or given angles. The first shape is a shape of a sector where the angle at the center is 60 degrees and the radius is 3 centimeters. We are now supposed to find the distance or the perimeter around this particular sector. So we'd say that for us to be able to calculate the perimeter around this particular figure, you need to come from this particular point to that, then the curved place, then from this particular side back to the origin or where we started. So in that particular case, we say that the circumference of this curved surface will be given by theta all over 360 multiplied by 2 pi r, where r is the radius of the whole circle. Then we add, this is the radius and also this is the radius, so we add twice r. Our theta is the angle subtended at the center. In this case it is 60 degrees, so we take 60, we divide by 360, you multiply by 2, the pi we'll use 22/7 multiplied by the radius, which is 3 centimeters, plus 2 multiplied by the radius, which is 3. So this first part, when calculated, 60 divided by 360 will give us multiplied by 2, multiplied by 22/7, then multiplied by 3 will give us 3.142857,143 plus 2 multiplied by 3, which will be 6. So when you add 6 to a total of 3.142, it will give you 9.142,857,143 centimeters. So I've said that because it's a sector, it's not a full or a complete circle, then for you to find the perimeter of this particular shape, then you need to consider this particular distance, the curved distance, and also this other distance, which you have said is going to be equal because they are part of the radius of the whole circle. So that's why we added 2r. Part B, we again have a sector. In this case, our radius is 3.5 meters, and the angle subtended at the center of the circle is 130 degrees. So again, for us to get the perimeter of this shape, we need to move from this particular point to that point, get the curved distance, then again from this point to this other point. So beginning with the curved distance, let's say point A to B through C, that one will be given by theta all over 360 multiplied by 2 pi r plus these two distances, which are the radiuses, that is twice r. So when we make the substitution, the angle subtended at the center is 130 degrees, so we shall have 130 degrees divided by 360 degrees multiplied by 2 multiplied by 22/7, which is our constant pi, multiplied by the radius, which in this case is 3.5 meters. Then the whole of this should be added to 2 multiplied by 3.5, which is the radius. So the first part, that is 130 divided by 360 multiplied by 2 multiplied by pi multiplied by 3.5 gives us 7.94444 is recurring, plus 2 multiplied by 3.5, which gives you 7. So when added to 7.9444, that will give us 14.94444, which keeps on recurring. So the correct answer will be 14.94 recurring meters. That is the distance around this particular shape. The final example on how you can be able to get the perimeter of a sector, we want to consider a case where you want to find the perimeter of the larger or the major sector. So this is part C of our question. That is the major arc, which I've been told that the angle here is 265 degrees and that the radius is 5 centimeters. So if you want to go around this particular shape, then you need to move from this point, go through the curved surface up to here, go back to the center, then come back to the starting point. So that means for you to get the total distance you'll have covered, you need to get the perimeter of this curved surface, which will be given by theta all over 360 multiplied by 2 pi r plus, again, this will be the two radiuses, that is 2r. So when you make the substitution, the angle subtended at the center by the major sector is 265. So this will be 265 divided by 360 multiplied by 2 multiplied by 22 over 7 multiplied by the radius, which in this case is 5 units or 5 centimeters, plus 2 multiplied by the radius, which in this case our radius is 5. So the first part will give us 23.13492063 plus 2 multiplied by 5 will give us 10. So when added to 10, this will give us 33.13492063 centimeters, because the units were in terms of centimeters. And this will now be the distance around the curved surface of the major sector plus the two radiuses, or the distance covered when you move through the two radiuses of that particular sector. I like to give an assignment on this. That is how we calculate or find the circumference of a distance around a curved surface or a circular surface. In the exercise, it involves a Ferris wheel. So we are told that a large Ferris wheel has a radius of 21 meters. A radius of 21 meters. Question is, find the distance a person will travel on one rotation of the wheel. Part B, a ride includes 6 rotations of the wheel. It includes 6 rotations of the wheel. What distance is traveled in one ride? So try working this one out, where you are given a large Ferris wheel which has a diameter, a radius of 21 meters, we're supposed to use the formulas for finding the circumference of a circle to determine the distance covered when the wheel rotates once, or when you go for one complete rotation. Then if a ride includes 6 such rotations, then what distance will be covered in one particular ride or journey? So that brings us to the end of how we can be able to find perimeters and circumference of sectors. Let us now turn and look at how we can be able to find areas of simple regular shapes. Now, we have got different formulas that are normally used to calculate different areas of different shapes. And in this case, or in some other cases, we shall be talking about the surface area of a particular object that it occupies on a given particular region. We shall basically look at how we can be able to get the area of a square, how to get the area of a rhombus, how to get the area of a rectangle, how to get the area of a parallelogram, also a trapezia, a kite, a circle, and also the sectors. But before we are able to look at how we can be able to convert that, it's important to know how to convert some units of area. Units of area includes square kilometers, square hectometers, square decameters, square meters, square decimeters, square centimeters, and also square millimeters. From one particular unit to another, we need to know how we can be able to convert them. So let me arrange them in the horizontal manner. So if you have kilometer square, followed by hectometer square, followed by decameter square, followed by square meters, followed by decimeter, followed by centimeter square, lastly millimeter square. So if you are moving from a kilometer square to hectometer square, then you multiply this one by 10 squared. If you are moving from hectometer square to decimeter square, you multiply by 10 squared. If you are moving from, this arrow should be pointing that way, from decimeter square to meter square, you multiply again by another 10 squared. If you are moving from this meter squared to decimeter square, you multiply by 10 squared. If you are moving from decimeter square to centimeter square, you again multiply by 10 squared. And if you are moving from centimeter squared to millimeter squared, you multiply by another 10 squared. But in most of the examples and in most of the questions that will be given, it shall only be encompassing of conversion of either from or to kilometer square, meter square, and centimeter square, and also at some few instances millimeter square. But when you are going back from millimeter square to centimeter square, we now don't multiply, we now divide by square of 10. If you are moving from that, you divide by the square of 10. From this to this, you divide by a square of 10. From this to this, you divide by a square of 10. From hectometer square to kilometer square, again you divide by a square of 10. So we have the only three important, which is kilometer square, meter square, and centimeter square, also millimeter square. We can be able to convert from kilometer to meter square by multiplying whatever you have here by 100 squared. No, I mean 1000, because there are 3 zeros from here up to there are 3. So you multiply by 1000 squared. From meter square to kilometer square, you do the opposite. That means we divide by the square of 1000. And when you're moving from square meters to square centimeters, you are here, it's there. That means you multiply by 100 square, 100 squared. But when you're going back to meter square, we divide it by 100 squared. Then if you're moving from centimeter square to millimeter square, then we multiply by 10, because that was the only difference. So multiply by 10 squared. But when you're moving from millimeter square back to centimeter square, you divide it by 10 squared. So that is basically on conversions. Let us look at how we can be able to find areas of different regular shapes. The first one is a square. A square is a figure in which all sides and even all the angles inside are equal. The distance from this particular place will be referred to as the length. Is the length. Also, the distance from this particular place will also be referred to as the length. And therefore, if you want to find the area of a square, you take the length, you multiply by the length, which will give you square of the length. Example. If we have a square that is measuring 4 units by 4 units, then for you to get the area, we have said it will be given by the length multiplied by the length. So in this case, the area shall be 4 multiplied by 4, which will give us 16 square units. All the units of area are squared. That's why the area of this particular square, where the length is 4 units, will become 4 by 4, which will be 16 square units. Part B, rectangle. A rectangle is a figure in which two opposite sides are equal and parallel. This side is equal to that side and they are parallel. This side is equal to this side and they are also parallel. The distance or the length of the longest side is normally referred to as the length, while the shorter side of a rectangle is normally referred to as the width. And therefore, for you to get the area of a rectangle, you will have to multiply or get the product of the length and the width. Example, if you are to find the area of a rectangle which has a length of 6 units and a width of 3 units. Then we have said that area is length multiplied by the width, and in this case area shall be the length, which is 6 units, multiplied by the width, which is 3 units, which will give us 18 square units. Part C can have a triangle, and we have got different types of triangles. We have a right angle triangle, we have an isosceles triangle, we have a scalene triangle where none of the sides or none of the angles are equal. So one of the basic formula for finding the area of a triangle, if we have this kind of a triangle where this side is the base, a perpendicular from the top to meet the base line is referred to as height. Then if you want to get the area of this triangle, you take a half, you multiply by the base and the height. So multiply by the base multiplied by height, which will result to a half BH. Example. So if you are given a triangle where the base is 6 units and it has the height of 4 units, then area will be given by a half multiplied by base multiplied by the height. In this case, our base is 6 units, our height is 4 units. So 2 will go there once, 2 will go into 4 twice. This will leave us with 12 square units. That means the area of this particular triangle is 12 square units. What if you have a scalene triangle where all the sides and all the angles are not equal? Like you have A, B, then part C. Then for you to be able to find the area of this particular triangle, you need to use a certain formula called the Hero's formula, which says that the area of a triangle will be given by the square root of S in this case being the average of the 3 sides of the triangle. That means for you to get S, you take A plus B plus C and you divide it by 3 into S minus the first side multiplied by S, subtract the second side multiplied by S, subtract the third side, which is C. But in the case you are given 2 sides of this scalene triangle and some included angle theta, then we use what we call the sine rule. We use not sine rule, but actually we use a formula that consists of the sine of this particular angle, and therefore the area will be given by a half multiplied by the side that you have been given, the 2 sides, that is A and B, multiplied by the side of that particular angle theta. Part D, or another simple figure, is a parallelogram. Now with a parallelogram, 2 opposite sides are also equal and parallel. In this case, this side is parallel to that side and they are also equal, while this side and this side are parallel, and they are also equal. So you can be able to find, if you are given this particular perpendicular height from the two parallel sides, it will be referred to as the height, while this will be the base. So if you have a parallelogram, or sometimes which also applies for a rhombus, then for you to be able to find the area, its area, you simply take the base and you multiply by its height. Example of such is, if you have such, where you have the height as 2 units and the base as 8 units, then we have said that area of the rhombus or that parallelogram will be given by the base, which is 8, multiplied by the height, which is 2, which will give us 68 square units. Part E is a trapezium. We have got different types of trapeziums. We have a right trapezia, which has one right angle. So if you are given such a trapezia, this will be the height. The longest side can be referred to as A, while the shorter side can be referred to as B. And this line and this line are always parallel. So in case you want to get the area of a trapezium, you normally take a half multiplied by the sum of the two sides, that is A plus B, then you multiply everything by the height. Example, if we have a right trapezia where you have been told that the height is 4 units, this side is 6 units, and this side is 5 units, then the area, as we had said, will be given by a half into A plus B multiplied by height, where A and B are the two sides of that particular trapezia. H is the height. Then this will be a half multiplied by 5 plus 6 multiplied by the height, which is 4. 2 will go into 4 twice, and therefore 5 plus 6 is 11. 11 multiplied by 2 is 22. 22 square units. Part F, or another type of figure, we can have a rhombus now. A rhombus is a twisted square where all sides are equal and opposite sides are parallel. For this particular case, you take the diagonal of that particular rhombus. This will be X, and this other one to be Y. And therefore, for you to get, these are rhombus. For you to get the area of a rhombus, you simply need to take a half, the product of the diagonals, a half into product of diagonals. And in this case, the diagonals are X and Y, so that will be a half multiplied by X multiplied by Y, which will be a half X, Y. Example, if you have a rhombus where the diagonals are 6 units and 8 units respectively, you can be able to find the area by taking a half into the product of those particular diagonals. So 8 multiplied by 6 is 48. 48 multiplied by a half or divided by half will give you 24 square units. We also want to consider the kites, how to get the area of a kite. So with a kite, it can be divided into two different triangles, where this side and this side are equal, where else this side and this other side are also equal. So if you take this distance to be x, then this distance to be y, which are the diagonals of that particular kite, then area shall be given by a half multiplied again by the diagonals, x and y, that is times x multiplied by y, which will again give us a half x y. If you have a circle, how do you get the area? Where you have that as the center and that as your radius. So for a circle, area is normally given by pi r squared. That is, you take the constant pi and you multiply by the square of r, which will give us pi r squared. What if it was a sector, not a complete circle? Where this is now theta or angle theta, or it's subtending the sector to subtend an angle theta at the circumference of the circle. You see this, for the full circle, it could be taken to be 360 degrees, all over 360 degrees multiplied by pi r squared. So in case you're only taking a section, that will be it will be theta all over 360 multiplied by 2 pi r, where theta will be the angle subtended at the center of that particular circle. Find the area of each of the following shapes. Shape 1, we have a rectangle. We say that for a rectangle, opposite sides are both parallel and equal. We are told that the length is 7 meters and the width is 3 meters. Now for this particular case, if you want to get the area, it's a rectangle. Therefore we say that area of a rectangle is given by the length multiplied by the width. Our length in this case is 7 meters multiplied by the width, which is 3 meters. That will give us 21 square meters. You take the length, you multiply by the width. Number B, we have trapezium parallelogram. We have a parallelogram which has a height of 1.5 centimeters and one of the longest side is 3 centimeters. We'd say that for you to get the area of a parallelogram, you take a half multiplied by the base multiplied by the height. Now the base of this particular parallelogram, because the opposite sides are both equal and parallel, if that is 3 centimeters, also the base is going to be 3 centimeters. So this shall be a half multiplied by the base, which is 3 units, multiplied by the height, which is 1.5 units. So that will give us 2.25 square centimeters. Finally, to wind up on areas of different shapes, I want us to consider a case where we're going to find the area of a circumference, of a circle, and also area of a sector. That's example 2. We are told find the area of the circle, find the area of the circle and sector correct to 2 decimal place. Part A is a circle which has a radius of 5.1 centimeters. I would say that for you to get the area of a circle, you take pi r squared, where pi is a constant ratio, multiplied by the square of the radius. So in this particular case, the area shall be 22/7 multiplied by the radius squared, that is 5.1. 5.1 multiplied by 5.1. 5.1 squared multiplied by 22/7 will give us 81.74571429 square centimeters. But the question is limiting us to 2 decimal place. Therefore, our correct answer to 2 decimal place shall be 81.75 square centimeters to 2 decimal places. Part B is a sector of a circle which is subtending to 60 degrees at the center and has a radius of 4 meters. We say that for you to get the area of a sector of a circle, you get the theta, which is the angle subtended at the center of the circle. You divide by 360 and multiply by pi r squared. So in this case, our theta, which is the angle subtended by the major sector, is 260 degrees divided by 360 multiplied by 22/7, which is pi. Then the radius is 4, and we are squaring the radius. That means we take 4 by 4. So 4 squared multiplied by 22/7 multiplied by 260 all over 360 will give us 36.31746032 square centimeters. But again, the question is limiting us to write our answers correct to 2 decimal place. So this shall be approximated to 36.32 square centimeters. And this is to the nearest 2 decimal places. Finally, I'd like to leave you with an assignment. On how to find the area. Number 1, a valuer who estimates the values of at the prices of lands tells you that your piece of land has an area of half a square kilometer, i.e. 0.5 square kilometer. How many square meters How many square meters do you have? Question 2. A rectangular park covers an area of 175,000 square meters. Give the area of the park in square kilometers. So these two assignment questions bring us to the end of the discussion on how we can be able to find area of different shapes. Important to remember is how to get the area of one, the square, which we said is length squared. How to get the area of a rectangle, which you said you take the length multiplied by the width. How to get the area of a circle, you said you take pi, you multiply by the square of the radius. And for the triangle, it's also important for you to know how we get the area, which you said you take a half, you multiply by the base, you multiply it by the height. Thank you.